G'day everyone, this is Michael from the Kubeapps team at VMware, just with another demo, this time a little bit more technical about how we do some of the things we do in Kubeapps. In particular, let's have a look at the problem. So if I click, currently I've got this Kubeapps installation set up to enable two different plugins. One returns packages from Helm, the other returns packages from Carvel. Now, if I click on the catalog here, you'll see that it starts sending me pages and pages and pages. It's adding another page every few seconds. And if you look closely, you can see there's Helm charts here, there's Carvel packages, there's more Helm, another Carvel package. Now these are all returned in order and as part of the response straight to the UI. So the UI does not have to care whether there's different plugins enabled. It's just saying to the API server, show me all the packages. And the API server is returning them in order from the different plugins. How does that work? So this brings us to my favorite design pattern currently, and that is the fan out, fan in, which with Golang, which is the language that we use to do most of the backend work in Kubeapps, is provided by two separate mechanisms. So one are Go routines. Now a Go routine is a very thin and lightweight execution thread. So it allows you to run different things concurrently. And channels are a mechanism to be able to send messages between concurrently running Go routines. How does that work? That all sounds very complex. I've got a demonstration of this which will make things easier. So let's just have a quick look. The way Kubeapps is set up, I think I've got that open here. So we've got a Kubeapps API service, and it can be configured with a number of different plugins. So Helm, Flux, or Carvel, for example, or some combination thereof. Now, the way this works when a request comes in, and now I couldn't think how to demonstrate this too well. So I've got this diagram here, which is pretty lame, but I've got an exciting demo with an actual game called Infinifactory, which I'll show in a tick, which makes, it animates the process. So but basically the request comes into our API service, and that creates one Go routine, which listens to the three input channels, one per plugin. Now, each input channel, this Go routine then spins up separate Go routines, one for each plugin. So one for Helm, one for Flux, and one for Carvel. And each of these Go routines each of these plugins knows how to fetch a page of results starting at a certain offset. And all each Go routine here is responsible for is fetching a page, sending them one by one down the channel. And when it runs out and exhausts that page, it fetches another page, for example. Let's have a look at how that works in practice. Welcome to Infinifactory. So this here represents our API server, which is going to request 6 items and send them back to the client, for example. Now stepping out, we have 3 plugins right at the back that you can see there. One, Helm, the first one, and we have Carvel, and we also have Flux. Now the problem is how we're going to get the information from those plugins sent back to the client, to our API server, in order, in the way that we expect. So to start with, let's just assume that we've got one plugin enabled. So the request comes in, and we'll ignore the middle part. It goes straight through to our Helm plugin, the only plugin that's enabled. And this request is for 6 items. So we'll just put 6 items onto we'll request a page of 6 items, which is there. Now, this next section here, this is the Go routine that's responsible for this plugin, and all it needs to do is to ensure that it sends items one at a time down that channel. And you can see each time one comes down, it arrives at the Go routine for the API server, which at the moment simply forwards it on down to the API server. So here comes the last one, and our API server, the handler goes, great, there's 6, I'll ship that off back to the client. Wonderful. Now, how does that work when we've got 3 plugins enabled? Let's take a closer look. So again, we're going to say that there's a request that comes in for 6 packages across all plugins. So what happens is that each Go routine here for the plugin receives a request to send 3 packages. Go. So the requests come in, and each that could happen concurrently. Obviously here it's not. And now all that's required is that each of these Go routines, one for each plugin, is responsible just to make sure that there's an item sent down each channel. Now the main Go routine, It sits here and compares all three of these items and says which one is the smallest. Great, this is the smallest one, send that one down the line. Automatically, the other go routine fills that place again. We do another comparison, find the next smallest item, send that down the line. It goes back to the server, and again, we go through, same process continues on, and we keep, this go routine simply just has to keep comparing the three options and seeing which one's the smallest. Now, this go routine has run out and requests another page of results from its plugin, and so that we're all each plugin has sent one item down its channel, and we can continue on. The process just continues with this go routine, comparing the three options, sending the smallest one each time, until we finally have a mixture of different packages from different items, but fulfilling our request from the client. Now, this can easily be extended to request a second page. For example, all that's required is that each plugin already knows how to send a page of results from a certain offset. And so we simply make sure that we return those offsets for each plugin when we return. Very quickly, let's take a look at how those separate pages do actually come through. If we have a look here in the debugger console, I'm going to go to the Redux tab, which enables us to see the different actions that our client in this case is sending. The key thing that I'm looking for here is the receive installed package list. No, that's what happens. We want the available package summaries. Here we go, receive available package summaries. And so you'll see this is the first request this is the first result that comes back. Initially, the next page token that we were storing was empty, but the next page token that comes back with this first batch of 20 results tells us that the offset for the Helm packages is 18, and the offset for the Carvel, the cap controller packages, is 2. Now, the client does not interpret this at all. This is an opaque token. It just so happens that we're sending it as a JSON um, blob from our backend, but the client doesn't care about it. All it does is it sends it off with the next request as well, so that you'll see the second one that comes in. Our next page token comes back from the server saying that Helm packages is up to item number 33, and the Carvel packages up to item number 7, and so on. So that continues all the way through, and each time the backend plugin knows which offset to start with which plugin, until you get to the end, and finally it comes back. The last one, the Helm packages, was at 87, and the Carvel one's at 13, but it's then set to empty, and the client is already aware that that's the end of the request. That's the end of the pagination. So that is fan out, fan in with Golang in Kubeapps, how we provide aggregated results for, when the client says, show me the available packages on this cluster, this is how Kubeapps returns those aggregated results across the different plugins. Thanks for your time.